Okay, hurricane. What the most important characteristic of hurricane? That is eye, an eye wall. If you can understand this eye, an eye wall, then you can understand how hurricane works. Yeah, eye, an eye wall. Yeah. What's your guess? In the eye. Yeah. Low pressure. The pressure is the lowest. So we have data. This is Sandy. Yeah. Sandy was coming to New York. So there are three cosmic ring neutron stations in New York City. Yeah. I think up. Yeah. Not New York City, in New York. Yeah. So when Hurricane Sandy arrived, passed through the northeast of USA, so there is some record. Yeah, you can see the blue curve. In X is the day, October 24, 26, 28. This is indicate pressure variation. Then yeah, on October 30, you see this pressure is lowest. That is the center of hurricane of Sandy. That I pass over. So here you can see this is the record about this pressure variation from day and day and day. Yep. So the center of a hurricane is the lowest pressure. So here show you about vertical structure of hurricane, eye, and eye wall. For the eye, the lowest pressure, yeah, no wind, air is sinking, yeah. Air is sinking and sinking and sinking, drying and drying and drying. So that's a clear sky. You can see the sunshine. No, almost no wind. Yeah. So, yeah. How larger for the eye? It's about 20 to 50 kilometers. Just like New York City. Yeah, the eye of hurricane, right? Yeah. Okay. So let's watch watch the details of this eye and eye wall. Eye wall, strongest wind on eye wall. Heavy rain on eye wall. Air is going up. Yeah, rising. Yeah, the rising. Then, uh, then water vapor condense into the liquid water. That's rain, right? Yeah, that's a latent heat is released on eye wall. Yeah, so the opposite. On eye, air is sinking. On the clear, the sky is clear, right? On the eye wall, air is rising. Yeah, there is heavy rain, water, and the strongest wind. Yeah. So then sometimes there's 2.5 meters of water per day for the hurricane. Yeah, that's too much. Yeah. Okay, let's first understand how this air flow for the hurricane structure. On the surface, you see the surface. What is the airflow? What is the wind is blowing, right? Yeah. at the surface, this air come to the center, right? Yeah. We call this is convergent to the center. This warmest air convergent from the surface to the center. Why? Why? Tell me why. Because the center is low pressure. Yeah. Outside a high pressure. The wind is blowing from a high pressure to low pressure. Right? Yeah. So pressure difference caused airflow. How about at the top? The troposphere, tropopause, the top of troposphere. What is airflow? Yeah, listen carefully. There are a lot of multiple choice in your exam, in your final. Yeah. So at the top, air aloft. You see, the air is outflow, not inflow. This is called divergence. This air is move out, right? Why? Pressure difference. Where is the high? Where is the low? Yeah, in the center, aloft, pressure is high. Yeah, outside, low. Wind is blowing from high to low, from high to low. Got it? Yeah. So this air is a circulation, right? Yeah. So this from a surface convergence, aloft, divergent, then formulate circulation. Yeah. So this is the airflow structure for the hurricane. Yeah. And wind speed. You see on here, wind speed near the surface is the strongest. Yeah. That's a hurricane that's different from another storm. Another storm, jet stream, is the highest wind speed at the top. Yeah. So hurricane, no. Hurricane, strongest wind near the surface, near our house, near everything, yeah, near us, right? Yeah, that is not good. That's damage. Yeah. So that's near the surface, wind speed is the strongest. Then wind speed decreases with height. At the high level, wind is not strong, right? This is a hurricane. Okay, so strong wind is caused by strong pressure difference. Yeah. So here, red curve is pressure. Yeah. You see the pressure, yeah, at the center, at the eye is the lowest. Yeah. And near the wall, this pressure change too much. That means the pressure gradient is strongest. Strongest pressure gradient causes the strongest wind. Right? Yeah, that makes sense, right? Yeah, that makes sense. So you see this pressure from outside to center. You see this change have great change around a wall. So that's greatest wind speed happening there. You're right? Yeah. And and also you see this is pressure difference is caused by temperature difference. Yeah, you see the temperature. Yeah, this is temperature. Where is the high? Where is the low? Temperature is the highest, is the warmest at the center. You see, for the hurricane, the eye is the warmest. Warm eye. Yeah. And at eye wall, temperature has the greatest gradient difference, right? Yeah, variation is the greatest. So greatest the temperature difference causes greatest the pressure gradient difference. Great pressure gradient cause strongest wind. Yeah, at eye wall, right? Yeah. So this is tell us about the data parameter for the hurricane. Principle. What is the principle? Wind is caused by pressure difference, PGF, pressure gradient force. Pressure gradient force is caused by temperature difference. Yeah. This is the principle, pressure temperature. Yeah. So let me give you example, good example for to apply this principle. What example? You are New Yorkers. You must know sea breeze. Yeah, in the hot summer. So in the hot summer, in the afternoon, you see, oh, this air is so cool. Yeah, there's cool air from a sea. Yeah, sea breeze. That means wind from a sea. Yeah. So that air, cool air flow from a sea is called a sea breeze. Okay, here give you an example. Yeah, in the ocean, is land, New York City, right? Yeah, in the morning. So this in the morning temperature is the same, assume, between land and water. Yeah. So at 7 a.m. Yeah. So then you see temperature the same. You see the pressure as a bar is straight, right? Yeah. At the low level, pressure is higher. At the high level, pressure is lower. At the lower, at the lower. Yeah. So so as the solar radiation hitting the ground and the water in the morning, which surface, land or water, become warmer quicker? Which one? What's your guess? Yeah. Why? Land will become warmer faster. Why? Because specific heat is different. Land specific heat is lower. Absorb, receive a little energy. Temperature going up quickly. Water has the greatest specific heat. So yeah, this water absorb a lot of energy. Temperature change a little. Yeah. So the land become warmer quicker. So what the consequences for the pressure for the reservoir? Expansion. So this isobar expansion code that make this isobar coming together, warm like this isobar apart. Yeah. What does this mean? So you can see here the pressure must be greater than 900 millibar, right? Yeah. So here this pressure must be lower than 900 millibar, right? Yeah. So here's the high, here's the low. You need to know the center, right? Temperature, yeah. Temperature cause difference for pressure difference. So let's let's examine what is the temperature distribution. Yeah. So here is the center of the hurricane. Then you see the temperature. So here is 7 degrees C. How about here? 3 degrees C. Yeah. 3 degrees C, 2 degrees C. So here the warm, here the cold, here the cold. You see the temperature difference. Temperature difference causes pressure, pressure difference. You see on this column is the cold, cold. In the center is warm. I is warm eye. So this is the temperature difference. This temperature difference will cause pressure difference. Pressure difference will cause wind flow pattern. That's for the hurricane. Now, then come back. Then come back for the vertical structure of a hurricane. And you see here, yeah. So in the center, in the eye, it's warm. Yeah. So here is the cold. Yeah. That is the temperature difference. Yeah. A temperature difference will cause pressure difference. Will cause isobar different. Yeah. The warm isobar is passing. The cold isobar come together, right? Yeah. The eye is warm. Yeah. Isobar is passing. Yeah. So there is a temperature difference causes pressure difference. So here the high, yeah. Here the low. This is PGF, pressure difference. Yeah. Pressure gradient force. Here the high, here the low. Pressure gradient force. Right? Yeah. And this is the pressure gradient force, pressure gradient force. This is pressure gradient force that's driving, that drive this air convergence, moist air at the surface come together to the center, yeah, to the wall, to the air wall, then going up at the loft. This move out from a high pressure to the low pressure. Okay, so then you see this is just for PGF. Temperature difference causes the pressure difference. The pressure difference causes the airflow. Convergence at the surface. Divergence aloft. There's another force, CF, corrosive force, that change the direction. So in the north hemisphere, you see here diffraction to the right. That means here move in, right? Yeah, you see the move in here. Diffraction to the right. So here air is move out. Yeah, so for here this air move out. So that's a rotation. Rotation at the surface is counterclockwise. Yeah. However, pay attention. At aloft, you see this is the PGF. Diffraction to the right. Diffraction to the right. That means here come out. Air come out. Here, diffraction to the right. This means come in. This come in. Yeah. Aloft. Aloft. This airflow is clockwise. At the surface is counterclockwise. Yeah, you see the rotation direction is totally different at the bottom and the top, right? Yeah, so from here you can see how PGF and CF work together. Yeah, at the surface is counterclockwise. Aloft at the top is clockwise, right? Yeah, and let's see why stop here. Okay, you see in the eye air is sinking, air sinking. That's a cloud-free sunshine in a hurricane. Yeah, that's eye. Yeah, and at the surface counterclockwise. Yeah, that's aloft. At the surface, counterclockwise, aloft, clockwise. You see, this is the eye is warm. Yeah, so this is for the hurricane need a warm eye. Yeah, yeah, warm eye. So this will be very, very important why hurricane development needs the warm eye. Yeah, because the warm eye that cause isobar expansion that produce PGF at the surface, make the air convergence aloft, make this airflow divergence. Yeah, so here I show you a few multiple choice, maybe your homework or your exam. So the sky in the center of hurricane are often cloud free. This is because the air in the eye. What's your answer? Sinking. Right, yeah. So vertical structure of the hurricane shows the up level, water of the air. Yeah, yeah. Outflow and the surface, inflow of air. Yeah. Yeah, just before a storm becomes a fully developed hurricane, it is in which stage?